Alright, in this video we're going to go over quadratic functions and transformations, part 1. Alright, here's your vocab. Parabola, the graph of a quadratic function. A quadratic function is a function written in the form of ax squared plus bx plus c, where a does not equal 0. Alright, a cannot be equal to 0. Vertex form. The vertex form of a quadratic is f of x equals a, parentheses, x minus h, close parentheses, squared plus k, where a is not equal to 0. Axis of symmetry is a line that divides the parabola into two mirror images. And down here I have a picture of that. This dashed red line right here is the axis of symmetry, because as you can see, it divides this parabola into two mirror images. All right. Vertex of a parabola, which is HK, is the intersection of the parabola and its axis of symmetry. Here's the axis of symmetry. The blue line here, it's not really a line, it's a parabola. The blue parabola here is our, well, it's our parabola. So the point where they cross here is our vertex. In this case, it's 0, 0. Now, this is called the parent function of the quadratic. So it's the parent quadratic function, meaning the vertex is always going to be 0, 0. Your axis of symmetry is always going to be the line x equals 0. And if you go over 1, up 1, because, you know, this is x squared. All right, this is f of x equals x squared. So that means if you put in a 1, you get a 1 out. If you put in a 2, you get a 4 out. All right, so this is called the parent quadratic function. All right, and the parent quadratic function is always going to look like this. It is never going to change from looking like this. All right. Now, something important to remember with vertex form is this. This is x minus h. And the vertex, the x-coordinate of the vertex is h. All right. So since this is x minus h, if h is a positive number, this will still be x minus that number. If this is x plus h, that means h is a negative number. All right. And then of course k, whatever this sign is, indicates if k is positive or negative. If it's plus k, it's positive. If it's minus, say minus 2, then k is a negative 2. But h will always be the opposite sign of what is here. Okay. All right, what is the graph of f of x equals 1/2 x squared? What does that look like? All right, well, what we can do is make a simple table. You can always make a table to graph something. So x, and in the middle here, you could put your function, and then your y values. All right. Now, since we've gone over transformations a little bit before, we know that this graph has not moved left, right, up, or down because there's no addition or subtraction in here. So we know that 0 is going to be in the middle because we know the vertex of the parent function is 0, 0. So let's go negative 2, negative 1, 0, 1, and 2. Let's plug in these values. So if you plug in a negative 2, what are we going to get? Well, negative 2 squared is 4. So 1/2 negative 2 squared, that is 1/2 times 4, which is 2. If we plug in a negative 1, we get 1/2 negative 1 squared, which equals 1/2. If we plug in a 0, of course we get out 0. If we plug in 1, we're going to get 1/2 times 1 squared, which is 1/2. And if we plug in 2, we're going to get 1/2 2 squared, oops, which equals 2. All right. So we can use this to plot it. We know our vertex is 0, 0. All right. We know at 1 it's 1/2, so go over 1, it's up 1/2. And if we go over to 2, we know it goes up 2. and then back to -1, it goes up 1/2. Back to -2, it goes up to 2. So that's technically enough points to graph our parabola. If we wanted to add more, we could. Let's go ahead and jump out to -4 if you want to. 1/2, -4 squared. -4 squared is 16. Half of 16 is 8. And if you plug in a 4, you're also going to get out 8. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. And then 3, 4, up to 8. Now, you just simply connect the dots with a smooth curve. Now, I'm bad at drawing on this, so if I miss some of these points, I'm sorry. Like I just missed that one. So there's our parabola. That is what the graph of 1/2 x squared looks like. All right. Again, you can just make a quick table to graph it, and you just get you some points and plot it. Now, what would be the vertex of this graph? Well, we've kind of already said it. The vertex is right here, so that means it is 0, 0. And of course, our axis of symmetry is going to be the y-axis. All right, our axis of symmetry is going to be the y-axis. All right, I want you to try one now. It says, what is the graph of f of x equals -1/3 x squared? And what can you say about the graph of the function f of x equals ax squared if a is a negative number? So graph this and answer the question. Here we go. Here's the table made. I chose -4, -3, 0, 3, and 4 just so some of my numbers came out nicely, but you could have picked, again, you could have picked -2, -1, 0, 1, and 2. It's up to you. The points don't matter as long as you graph them right. All right, so when I put in -4, I got -5 and 1/3. When I put in -3, I got -3. When I put in 0, I got 0. When I put in 3, I got -3 again. And when I put in +4, I got -5 and 1/3 again. All right. So this is what your graph should look like. Here's my points, and here's what your graph should look like. Now, what can you say about the graph of a function f of x equals ax squared if a is a negative number? All right, well, if a is a negative number, it simply means that the parabola points or opens downward. The parabola opens downward. All right. So when a is a negative number, the parabola opens downward, just like right here. A was negative, so it's opening down. All right. Now, these two highlighted words, minimum value and maximum value, are vocab words. So I want you to write this down. All right. Key concept: reflection, stretch, and compression. All right, reflection, A and negative A. So, of course, if A is positive, it opens up. If A is negative, it opens down, and it causes a reflection over the x-axis. If A is greater than 1, it causes your parabola to stretch. And if A is between 0 and 1, it causes a compression, just like with the absolute value, okay, that we've learned about. So, if A is less than 0, the parabola opens upward. Okay, we just went over that. The y-coordinate of the vertex is the minimum value of the function. So if you look right here, all right, this parabola opens upward. It's y equals x squared. And our vertex right here, this is the lowest this function is ever going to get. All right, it's the lowest it's ever going to get. So therefore, your y value here is the minimum of the function. And the same thing if a is negative. All right, this is the highest this function is ever going to get. So that means the y-coordinate of your vertex is now a maximum value. All right, so if it opens up, the y-coordinate of the vertex is a minimum. If it opens down, the y-coordinate of the vertex is a maximum. Remember, a negative a opens down, creates a maximum. A positive a opens up, creates a minimum. Make sure you have that written down and you understand it. All right, graph each function. How is each graph a translation of f of x equals x squared? So here we have g of x equals x squared minus 5. All right, we've gone over translations with the absolute value. So this works the same way. If you're adding a number, adding or subtracting a number to the x squared, just like we have here, that means it's either going to go up or down. If you're subtracting, subtraction goes down and addition goes up. So the only thing that happened here is we took our parent function, remember our parent function that we went over at the beginning of the video. All this negative 5 means is our parent function moved straight down 5 units. So therefore our vertex went from 0, 0 to 0, negative 5. If you were to make a table of values for both of these functions, you would see that the x's would be the same, but each y value would be 5 less for the blue parabola versus the red one. All right. So when you're adding or subtracting to the x squared, you're moving upwards if you're adding. I got that backwards. You're moving upwards if you're adding, and downwards if you're subtracting. All right. Like in this case, we're minus 5, so we're going down. Now, if we look over here, the 4 is subtracted directly from the x. It's in parentheses with the x. Anytime you have a number added or subtracted inside the x, that means it moves left or right. If it's positive, if you're adding, it goes left. If you're subtracting, it goes right. So since we're doing x minus 4 quantity squared, that means we're taking our parent function and moving it to the right 4 units. So therefore, our vertex changes from 0, 0 to 4, 0, because all of our y values stay the same, all of our x values increase by 4. All right. Now, what this also does is it takes our axis of symmetry from x equals 0, which is the y-axis. All right. When you have just a vertical translation, it doesn't change your axis of symmetry. When you have a horizontal translation, it changes your axis of symmetry. Your axis of symmetry will always be equal to your x-coordinate of your vertex. All right, so x equals 4. Here, x equals 4. So therefore, x equals 4 is our axis of symmetry. All right, because your axis of symmetry will always equal the x value of your vertex. Okay. All right. You don't have to graph these. But how is the translation of f of x? How is it a translation of f of x equals x squared? All right, so we have g of x, which is x squared plus 3, and h of x, which is x plus 1 quantity squared. So pause the video and figure out how these are translations. All right, so we have x squared plus 3 right here. Well, since the 3 is added to the entire x squared, that means we're moving up, all right, and we're going to move up 3 units. All right, so our vertex is going to go from 0, 0. If we move straight up 3 units, our x-coordinate's not going to change, but our y-coordinate is going to change by 3, so our new vertex will be 0, 3. All right. All right, because all we did, we took our parent function, which has a vertex at 0, 0, and we moved it straight up 3 units. That's what this plus 3 does. So 0, 3 is our new vertex because our x-coordinate did not change, but our y value increased by 3. H of x equals x plus 1 quantity squared. Now, since this is inside the parentheses with the x, we know it moves left or right. Since this is a plus, we know we go to the left 1 unit. So our vertex goes from 0, 0. All right, all of our y values stayed the same because we're moving left and right. So our y value is still going to have a coordinate of 0, but all of our x coordinates are going to move left by 1 unit. So when you're moving left, that means it's going to go from 0 to negative 1. So this is our new vertex. All right. I know I didn't have you do the vertices, but I decided to. Now here, our axis of symmetry, AOS, didn't change, right? Because we moved straight up. So our axis of symmetry is simply x equals 0. But here, remember, since we moved to the left, our axis of symmetry is going to move also to the left. And remember how I said your axis of symmetry is always equal to the x value of your vertex? So our axis of symmetry, in this case, would be x equals -1. All right, like I said, your axis of symmetry is always going to be equal to the x coordinate of your vertex. All right. All right, last thing. For y equals 3, quantity x minus 4 squared minus 2, what are the vertex, the axis of symmetry, the maximum or minimum value, and the domain and range? All right, so let's look at our vertex. All right, we know that vertex form is f of x equals a x minus h squared plus k. And we know that h and k is our vertex. All right, since we're x minus 4, and this is x minus h, we know that the x coordinate of our vertex is 4, and since this is minus 2 and this is plus k, we know that our y value is minus 2. All right, so that's how you get your vertex. You look at this number, take the opposite sign here, minus 4, this is positive 4. Then you look at this number and take the sign in front of it, so -2. All right, what is our axis of symmetry? Axis of symmetry. If you remember, your axis of symmetry is always going to equal the x coordinate of your vertex. So our axis of symmetry in this case is going to be x equals 4. All right, now we're going to have a maximum value or a minimum value. Well, in this case, since a is greater than 0, meaning a is a positive number, that means we're going to be opening upward like this, which means our vertex here is going to be a minimum. So we're going to have a minimum, and now your minimum is going to match the y value of your vertex. All right, it's going to be the y value of your vertex. So our minimum occurs at x equals 4, and it is y equals -2. All right, some places you'll see that it'll say that k equals -2 is a minimum. All right, both of these say the same thing. It just depends on how the person that writes it feels like writing it. You could say your minimum occurs at x equals 4 and it is y equals -2, or you could say k equals -2 is a minimum value, or just a minimum. All right, now the domain. We know the domain is all the x values that you can put in. Every single x value that you can put in. Well, we have no constraints here for plugging in x values, so our domain is simply going to be all real numbers. All right, you can write that as all real numbers that way with 2 bars on your r, or you can write an interval notation, which is -infinity to infinity. All right, and now our range. Now, since we know that -2 is our minimum value for y, and the range is all the y values, we know that the smallest this can get, that our y values can get, is -2. All right, so we know that -2 is the smallest it can get, and it's going to open upwards forever. All right, so our range is going to be including -2, infinity, because we know that since k equals -2 as a minimum, we know that -2 is going to be the smallest it can get, and then it'll go on to infinity and beyond. All right. So here's your got it. Basically do the same thing with this problem that we just did for the last one. Find your vertex, axis of symmetry, max min, and domain and range of the function. So go ahead and pause the video and figure this out. All right, and here we go. Your vertex, remember, HK. So H is -1 because this is +1. Remember, you always take the opposite of the sign. Our vertex is -1, 4. Your axis of symmetry is x equals -1 because remember, your axis of symmetry is always equal to the x-coordinate of your vertex. Your maximum, since this is negative, we know it opens downward. So we know that the y value of the vertex is going to be our minimum, so our max is k equals 4. And our domain, again, there's no restrictions, so it's all real numbers, or the interval notation, -infinity to infinity. And our range, remember, is our y values. So, oops, this isn't supposed to be negative. I wrote that wrong. And our range is going to be, it's all the possible y values you can get out. We know 4 is the largest, so it's everything less than 4. So interval notation is -infinity, 4 with a bracket. Or you can just say y is less than or equal to 4, because 4 is the largest this can get. All right. So that's been your quadratic functions and transformations part 1. Make sure you understand the concepts of this video. Feel free to watch it as many times as you want. And make sure you come to class tomorrow ready to work some problems. See you tomorrow.